a classical breakout game in JavaScript. So let's get started. Alright, welcome back. I'm here on my desktop computer and I open the code editor where I'm gonna type the JavaScript code, and eventually we're gonna create this breakout clone in JavaScript. But before that, let me grab my notebook and plan a little bit this game to see how we intend to design it, what we want to accomplish, and so on and so forth. Probably you're already familiar with the breakout game. So without further ado, let me switch to my notebook here. And let me draw the canvas here. I'm gonna try to present you the rules of breakout game while I'm gonna draw. So this is the canvas, and we have a canvas of 800 by 600 resolution. This is the resolution that we use for this kind of activities here on the channel. And basically with breakout game, we have here a series of bricks. I think they're called bricks, if I'm not mistaken. There is not a certain number of bricks, can vary, and actually if we design this one with levels, maybe it can vary from level to level, and we can have even more than one level of bricks, like this. Let me draw all of them. And then the other part is that we have a paddle here at the bottom. At the bottom of the screen we have a paddle that we can move left and right using the arrow keys, and on the paddle we'll start having a ball basically, and in the moment we're gonna press space, we are launching this ball, and this ball is heading straight towards the bricks. And let's say if it hits the walls, it will reflect from the walls, and at one point it'll hit one of these bricks. And in the moment it hit a brick, this brick will basically disappear, and the ball will come back, reflect from the walls, and we'll have to maneuver our paddle to catch the ball, and then we're gonna hit and try to destroy all the bricks. So the objective of the game is to destroy all the bricks in a level in order to advance to the next level. Alright, so perhaps we should model our game using classes in JavaScript. Since we learned about classes recently, I think this is a great way to kind of do more practice using the classes. And I'm here in the code editor, and I'm gonna start defining the first big class. The first one will be called bricks, right? And the bricks class will basically contain all the behavior that will help us manage the bricks that are drawn on top of the screen. Perhaps another class that we can define here is the paddle. This will be the class that manages the paddle, the one that is moving at the bottom. And then another class will be the ball. And this is the ball that is basically reflecting from the walls and tries to destroy the various bricks. All right. Now, another important aspect when we design a game like this kind is to define a game loop. So this one is defined using the function loop here. And if you are using a different platform, or if you are using basically bare metal JavaScript, there is request animation frame available to you to define a game loop. But this simple function here available on the platform, just imagine it, the browser invokes it for you up to 60 times per second. So it's basically a game loop. And the main idea with the game loop is that we're gonna draw something on the screen, then we're gonna clear it and draw again, clear it and draw again, similar to basically the cartoons, how cartoons are designed, like frame by frame. So all we have to do basically in this game loop, we'll have to clear the screen, like we said, and we have to display something, and eventually update the state of the game all the time. And it's a good practice to kind of split the displaying and updating of the game state in two functions. Some people do it this way, other people, they combine it in one function. So we can have them separate, or we can have them in a single function. It's up to us. All right. Now, if we run the code right now, it will produce an error because display and update are not defined. What we can do is can define here a function display and then a function update. All right, so basically this is the structure for our game. And we want basically to kind of now fill in the blanks and complete the rest of the game. See how we can implement the bricks class, how we can implement then the paddle, the ball, and how we're gonna display them, and what we are doing here for the update. All right, now since we are encapsulating all the logic of the bricks, paddle, and ball in these particular classes, the display and update that are actually called from here, they're pretty simple functions. We're gonna just delegate the entire display to the ball, to the bricks, to the paddle. In other words, what we can do is basically these three classes, they can have a display and update method, and then the outer display one, the global one, will delegate to these ones. In this way, we don't put any kind of logic in here. We just delegate this one to the classes display and update. All right, so let's do that. Let's add a little bit more thing to the skeleton. So the bricks will have a display, as we said, a display method, and also an update method. And as a matter of fact, all these three classes will have this kind of structure with a display and an update. All right, so at this point, we can basically invoke those ones, right? But since these methods, because they are inside the classes, we need kind of an instance of those classes in order to invoke the methods inside. So let's create perhaps an instance of these classes. We'll need basically the bricks, the paddle, and the ball. And there is just one of them, right? So let's have here some constants. It can be constants, I think. We can use let for now. But so bricks is new bricks. And then we have the paddle is new paddle. And then we have the ball, which is new ball. Like this. And now inside, what we can do is say bricks.display, paddle.display, and ball.display. And for the update, we're gonna do similar things. So you're probably wondering at this point, display, what are the meaning again of this display and update functions? Well, display is pretty simple to explain. Its only job is to draw the particular object on the screen. So for instance, for the ball, we're gonna draw a circle. For the paddle, we're gonna draw a rectangle. And for the bricks, we're gonna draw a series of rectangles. All right, that's pretty simple, the display. But what about update? Well, update will be in charge with updating the state of the game, such as update the ball position on the screen, or read the keyboard, and then if basically the left key is pressed, update the X coordinate of the paddle, move it to the left, or if right key is pressed, move it to the right. This is the intent of this display and update functions. All right, so we wired up all these ones. Let's inspect again the code. So we have three empty classes here, bricks, paddle, and ball. We created instances from these ones, and then we have two global functions, display and update, that are calling the actual display and update of those classes. And from within the game loop, we are calling the display and update. All right, sounds pretty fine to me. Let's name this one Breakout clone, and I'm gonna save the program. Now, it's a good idea to run it, even if we don't expect to see anything on the screen because we're not displaying anything. At least we wanted to see if this skeleton has any error, because when we are running it, basically if there is any error, the system will report us an error to us. So it's always good to run your code from time to time to avoid accumulation of errors. All right, everything looks good. Perhaps now it's time to put a little bit of more useful code within this structure and have something on the screen. You know what? Also, these functions, these classes, is good to define a constructor for them. So let's go and define a constructor. We'll define one for the bricks, And we're gonna do the same one for the paddle and one for the ball. All right, so these are basically empty again. We see all these classes have a constructor, display, and update method. Let's see what we can do in the constructor for the bricks. Let's start with the bricks, perhaps, right? We can start with the pedal. That's another easy one. We can write the logic for the pedal and make it move left or right. But let's start with bricks this time. So let's define a few constants here, and this will be actually not constants in the sense of JavaScript constants, but will be like properties within the class. So one of them can be brick space. So, okay, I'm thinking to do this one. Let me switch to the notebook here. Let me see how many bricks I I put here. 1, 2, 3, 4, 5, 6, 7. Okay, so we have basically 7 bricks. Actually, we have 7 columns. These are 7 columns, and these are 2 rows. 2 rows. One way of implementing the bricks is to have basically this kind of constants. Okay, inside the bricks class, we define a constant for how many rows and how many columns. That will work just fine, and we can do that one. Another way is to basically define a constant for what is the width of a brick and let the system figure out how many columns can we fit on the screen. Probably we'll go with this method first. We're gonna define some constants for how many bricks do we want, or how many columns do we want, and how many rows, and we let the system actually figure out the width of a particular brick. Can also figure out the space, but I'm thinking that the space maybe we should provide it also as a constant, right? So the space between the bricks it can be expressed in pixels. Perhaps we should specify it in pixels, like 20 pixels, right? And this is 20 pixels, this is 20 pixels. Even on vertical, probably we can use the same constants, and this one to be 20, 20, something like that, right? And if we define the space as a constant, we can basically calculate really quickly what will be the width of a brick if we know how many columns we want. And rows, yeah, rows can be also constant because we don't want to fill the entire screen with bricks. That will be terrible. So we can have as constants basically. Yeah, let me come. I'll keep the notebook handy here close by. But let's define basically this brick space, like we said, maybe 20. And how many rows do we want? Maybe 2 rows. And how many columns? Maybe 5 columns. We can start initially with 5 columns. So this is, we start with this state. So in the moment we run, we expect to see 2 rows of 5 columns of bricks. So how do we create the bricks? First of all, we don't draw them on the screen directly. It's best to create them in some sort of variables, in a structure, because in the draw loop, we're gonna clear continuously the screen, so you have to redraw these bricks continuously from this structure, rather than having them drawn only one time on the screen. The other thing is that having them in a structure is very easy for us to remove a brick in case we are hitting it with the ball, right? So imagine the structure will be an array. Actually, we're gonna put them in an array. So if we hit a ball, we're gonna remove an element from the array at that particular index. So basically at one, we'll have to have these bricks in some sort of an array structure like this. And then, yeah, maybe let's have an internal private method called create bricks. And create bricks will actually be in charge of populating this array. So what this one will do, first of all, we'll need to figure out what is the brick width and the brick height. Not necessarily this method, we can also figure them out here. We can put inside here. Anyway, let's see what will be the brick width, and we are storing all these constants again in some internal properties. So let's say brick width. All right, back to the notebook here and figure out what will be the formula for this one. So in this particular case, we put in the code 5 instead of 7 is fine. But anyway, we have here 7 columns, but we notice that we have 1, 2, 3, 4, 5, 6, 7, 8. So basically, at any time on horizontal, we have, if we have n columns, we'll have n plus 1 spaces, right? So if we have 7 columns, we have 8 spaces. So therefore, the formula for to figure out the width is basically we are subtracting from the width of the screen, which is 800 in our case, n plus 1 spaces, right? Multiply, of course, with the space width with 20, and then we are dividing by how many columns they are, right? So in this case, we are subtracting from 800. There are 8 spaces in our case times 20. So we are subtracting 160. So we are subtracting all this white space in between the columns and at the end and at the end. And this one we are dividing by how many columns there are, by 7, right? So this will basically give us the brick width. So this is kind of the formula that we're gonna implement in the code. And then for the height, actually for the height we can have it as a constant, like we have the brick space. Yeah, we can have it as a constant, or you know, height can be also kind of expressed like maybe we want height of a brick to be a certain percentage of the width. So if we maybe 20%, 50%, something within that area. Anyway, so the brick width is the entire width of the screen, which is available in the constant width, or we can put here also 800 if we want, and we subtract that by this one, how many columns they are, plus 1, as we said, plus 1. So that's n plus 1, that n plus 1. We multiply it by this brick space, and at the end, everything we are dividing it by how many columns they are. That's I hope I wrote this correctly. So that should be the brick width, right? And then the brick height. And as we said, we can put this one here. They don't have to stay within the create bricks. That we're gonna invoke it. We have to invoke it immediately after. So brick height can be either a constant, maybe 20 pixels, or you know what? Let's have it like a certain fraction out of brick width. So perhaps we multiply by 0.4, or it's not quite half of the brick, right? So let's see how we're creating the bricks. We'll have to populate this array. Actually, let's have this create bricks create this array entirely like this. And now we have to loop through all the rows and all the columns and figure out what will be the x and y position of a brick based on that particular row and column. And we want to store in an array of small objects, and that will represent each element will represent a brick, and we want to store at least the x and y coordinate for those bricks, right? We can store also the row number and column number, but I'm thinking to store also the x and y, because from this point on, when the ball will move and will try to hit the brick, we'll have to compare x and y coordinates, not rows and columns, right? So and also when we are displaying them, in order to display them, we need to x and y coordinate for each brick. So let's iterate really quickly through all the rows. So for let row equals 0, row less than this dot rows, row plus plus, and we're gonna use a nested for loop here. For let call equals 0, all equal less than this dot calls, call plus plus. Alright, so we have two nested loops that allow us to iterate on these two variables. Right now we have to figure out what will be the x and y coordinate of each brick. And again, we need to figure this out a little bit here. So each of these bricks will have an x and y coordinate. Let's take this guy here, the second row, because this one is kind of crowded here. So what will be the x and y coordinate of this small rectangle? And the coordinates will be the top left corner here. All right, so x and y will basically, for the first one, is this space. So basically x equal that space plus, that's it, is the space for this one, the first one, right? What about the second one for this one? So, and actually, yeah, let's say for the second one or the third one, because the first one is kind of the trivial case. For the second one, we can consider each brick with each space that is following after it, or before it actually. Yeah, let's consider it before it. So let's look at this distance as this kind of, yeah, distances, right? So if we want to place a brick on the second position here, we need to figure out what will be the distance plus a space. And if we want to position it on the other one, we need to figure what will be, so they are for the fourth brick here. So this is brick 0, 1, 2, 3. Okay, so the brick number 3 here is basically, there are 3 bricks in front of it, and each brick will have a space plus a brick width, right? So it will be the column multiply with the brick width plus space plus an extra brick space, which is the one in front of it. And for the y is basically the same, right? So this one basically is space times column multiplied by brick width plus space. That will give us the x, and the y is basically, if we consider the same one, so basically this one will be the space plus, this time will be the row number multiplied by the brick height plus a space, because we have the same situation here. So this will be the kind of the two formulas that we're gonna try to implement inside our code. So let's say this one is basically this dot brick space, that's our constant, it's not called sp like we put on the paper, plus column, and this time without this because it's, we are referring to this particular column, multiply by this dot brick space plus this dot brick width. I think we got it right? Let's inspect it really carefully here. Yeah, I think we got it right. And if we can actually duplicate this one, and the y coordinate should be row here, and this one brick height. All right, we have the x and y. Normally we can draw them really quickly here. Let's draw them just to make sure that we have them right, and if we have them right, we're gonna put them in array after that. So let's have an rect at x and y, and basically is the brick width and brick height. Brick width, or this dot brick width, and this dot brick height. Let's make sure that we didn't mess up anything here. Oops, something is not right here. Oh, of course, because we are because we are clearing all the time the screen here. So if we are running this one, yeah, let's comment out all the code inside here. We just need the invocation here. For whatever reason is not working, and that reason is because we forgot to call bricks. So we created this function with the intent of not placing too much code within the constructor, but of course we have to call it if we want the code to be executed. So if we run it, create bricks is not defined, of course, because this is a method, it's not a function. We have to run it with this dot, and indeed we have 5 columns and 2 rows of bricks. All right, let's fix the code here. Let's fix the wiring. So we want actually this one to remain like that, because what we want to do is not actually display them immediately, but as we mentioned, we want to have this array of bricks and we want to push into the array of bricks a small object containing the x and y coordinates for each brick. Now we can also push, to make the program a little bit more generic perhaps, we can also push more attributes for each brick. We can push not only the coordinates, we can push also the width and height of the brick. We can push perhaps a color for the brick, and if we want to have different colors, and then each object will be standalone. Each brick will contain all these attributes. But I think at the minimum it's enough to have just x and y, because the brick width and brick height, they are global constants and they are the same for all the bricks, and we can also have all the bricks drawn in the same color. So so for now let's have them like that. And the next step that we have to do is, let me save the program. The next step that we have to do is to implement the display function here, or at least, yeah, this is the next step that I really want to do, is because I want to see the bricks drawn in the proper way. So for this one, what we'll have to do is to have a for loop to iterate through all the bricks. So let brick of this dot bricks. And for each brick, we're gonna draw it. Basically, we're gonna put now the rectangle here. This one, this time will be brick.x, brick.y, and because the bricks doesn't contain the width and height, we have to take them from the global ones, brick width, or from the class properties, and brick height. All right, and we can also define us before starting to draw, we can define a stroke. Perhaps we want to have a black stroke around them, and we can have a color. What colors are bricks? Orange? So let me run it. All right. It's a good accomplishment. At least we have the bricks drawn on the screen, and they are drawn in the proper way. They are drawn by the display method of the bricks class. And let's remember that this one is called from the loop, game loop, which basically clears the screen and redraw it, clears, redraw it, and so on and so forth. So apparently bricks are staying in place, which means that we did something good until now. Therefore, let me share this program with you on the chat if you want to load it on your side, as I'll basically save it from time to time. You'll be able to reload it and see there the delta. So this one is breakout clone. All right, the program is on the chat. So we have the we have the bricks. We can work on the update method now, but perhaps it's too much. Let's work a little bit on the pedal, and let's try to also see what kind of properties the pedal has and how can we render the pedal on the screen. So pedal is basically that small rectangle at the bottom of the canvas. So obviously you need to have at least an coordinate, some x and y coordinate for that one, and a width and a height for that one. And also, yeah, and also then we can just display it using a simple rectangle. So, as we said, we can have a width. Let's just use a simple variable like w for width. It's too verbose. The above code that we wrote is so verbose, it's hard to kind of not make mistakes. So let's have it like this dot width, which can be 100 pixels, or even better, we can have the width and height of the pedal send as parameters to the constructor. So we have to remember to go back in the constructor there, and when we initialize the pedal, we have to provide some size for the pedal, right? So can be 100, can be, but we have the chance from outside to change it, and also it's a good chance for us to kind of practice more different techniques for JavaScript coding. All right, so the same for height, we can send it and pass it as an argument, right? So we want to draw the pedal in the middle of the screen initially. So its X position will be, back to the drawing board, X position of the pedal. So if this is the middle of the screen, so this is width divided by 2. Width is the canvas width. So if this is the middle of the screen, this X coordinate is basically width by 2, width by 2, subtracting half of the pedal. So it's minus W by 2, right? The pedal has the width W from here to here. So we subtract this half of it. So we can just center it on the screen. All right. So X is basically, and we can put in a parenthesis together. So it's basically width minus this dot W, and we divide it by 2. And then the height, basically the Y coordinate of the paddle, we have the height. We can start from the bottom of the screen, which is available in the constant height, or we can put here number 600, and we can go above maybe 2 heights of the paddle, right? So this dot height times multiply by 2. So we don't put the paddle on the bottom of the canvas, but we raise it a little bit above. It's like there are 2 stacked paddle on top of each other. And let's go and implement the display, because we really want to see if this paddle is rendering correctly. So for the display, we're gonna do the same. We're gonna have a stroke black, and the paddle maybe we should have a feel of brown, or I don't know what kind of color is a paddle in Breakout game, but for sure we're gonna render it using a single rectangle at this dot X, this dot Y, this dot W, and this dot H. All right, let's see if we did something good here. Nope. Nope. Oh, did we invoke the constructor with the right parameters? No, we didn't. So maybe paddle should be, like we said, 100 pixel by 20, something like that. If not, we're gonna tune them. All right. Something is good. We have the bricks and we have the paddle. They are very, very static at this point. They are not moving. We can go and implement the ball now, and we can implement it, make it also static. But let's put a little bit of logic, because we wrote too much static code. Let's put a little bit of logic and see how can we move the paddle left and right. So the way we're gonna do that, we're gonna go in the update method of the paddle class, and we're gonna listen for keyboard. We're gonna check if it's left arrow press. If yes, then of course we can decrease the X coordinate by a certain amount of pixels. If it's right arrow pressed, we can increase by a certain amount of pixels, right? And then we are expecting that the pedal is just moving through the mechanism of the game loop. Basically, next time when the display will be invoked, X will be at a different position. So basically the rect will be drawn in a little bit different position, so it will appear that the pedal is moving. So in the update, we just manipulate the X and Y coordinates. That's it. And we don't do any drawing here whatsoever. But again, next time when the game loop is getting invoked, or this display is getting invoked, we'll find different values for these coordinates. So hopefully our pedal will move on the screen. All right, so let's check for if key is down, and we check for left arrow. And we can also say here else if key is down, and we can check for right arrow. So we said that if it's pressing left, we'll say this dot X, and we decrement it by a certain value. 1 pixel, perhaps it's moving so slowly. Let's choose 10 for now. And if we are pressing right arrow, we are incremented by 10 pixels. All right, let's save it and run it. And another accomplishment, our pedal is moving. Oops, but it goes outside of the screen. All right, of course, because we didn't put any logic to kind of make it stop at the left edge. So what we can do is say, if we press left arrow, we can go inside here and basically verify X coordinate. So before we decrement it, we verify where we are, or we can go here and create a complex condition saying if we press left arrow and this dot X is greater than 0, so the pedal is within the canvas, didn't get a chance to go outside, we decrement it. Now there is a chance to go a little bit out. For instance, if X is 5 pixels, to say X is 5 currently. Of course, 5 is greater than 0, and when we decrement it, we'll go a little bit 5 pixels outside, but it's fine. next time it won't go outside. So it's fine, this one, we can live with this kind of compromise. So the same we can do in the other direction, but here we can say, and if this dot x is less than width minus the pedal width, right? Minus this dot w, right? Because we don't want to go completely out. We want we want on the other side to stop somewhere here, right? So at this particular x, and this one is width minus pedal width. We don't want, because otherwise if we stop here it will go outside completely. All right, so I think the logic is correct here. Let's run it again. Test often. All right, it's stopping here and it's stopping in the other place. Looks good. At least to me it looks good. Now the pedal is not moving quite natural. It doesn't have an acceleration or deceleration. It's kind of computer movement, constant linear acceleration or velocity. But I think we should be fine with this one, at least for this particular game. We don't want to overcomplicate the logic. Perhaps in a future game we're gonna create an enhanced version where the pedal moves with some sort of acceleration, but for now it is fine. We should focus on the rest of the game and the rest of the logic. All right, so the pedal is kind of almost complete, if I'm thinking, right? Because what else we can do with the pedal? Move it left and right. Now let's move to the ball here and see what we can do with the ball. So first of all, we're gonna go in constructor and see what kind of properties a ball will have. And we said that initially the ball maybe should appear on top of the pedal, and from there it will be launched. And of course, at any point we'll have to keep the x and y coordinates of the ball. So first of all, let's have an this dot r, basically radius of the ball, which is a constant, really. We don't plan to change the radius of the ball in motion, but we store it in a property like that, just to be together with the ball class, right? And then, of course, a ball will have an x coordinate. We can initiate it with some, and a y coordinate. We can initiate it with some dummy variables here. But also, what we can do, yeah, let's initiate it with some dummy variables here for now. And also we need to basically display it. Okay, let's display it. The ball will be in two states. First of all, we're gonna think the ball can be on the pedal. So initially it's on the pedal, it sits on the pedal, and if we move the pedal left or right, the ball we expect to move with the pedal. So it will give us the opportunity to fine-tune our hit, so we can go with the pedal under a brick and then press space and the ball will launch. And the second state of the ball should be in motion, when it's basically flying around on the screen. Yeah, let's focus on the first one, when the ball is on the pedal, right? So let's go and display the ball on the pedal here. We have a problem. We are inside the ball class and we need to place the ball on the pedal, but we don't know about the pedal from here. The pedal, well, we can theoretically know, because the pedal is a global variable and initialized with an instance of this class, but that's not a good practice to access a global variable from within the class. What is nicer and actually better is to receive this one as parameter. So let's say the ball is actually receiving a pedal on the constructor, and we can even store it here. We can keep a internal reference to the pedal here, so we can have this dot pedal is pedal. Now, if we do this modification, when we are instantiating the pedal, or we are instantiating the ball, we have to pass the pedal here as an argument, which is this one. So right now, inside, the ball will not refer anymore to this global one, because this one is received by the ball. So we have access to the pedal in a clean way inside. All right, so now if we want to display it, basically we know exactly where the pedal is, because the pedal has pedal.x, or x, did we define it as x? Let's see. yeah, has an X and Y. So we basically right now know how to display the ball. It's at the pedal.x plus pedal width, middle of the pedal basically. All right. So maybe we should, instead of having this one as constants here, let's have them as no, it can be as constants for now. Anyway, let's display the ball. And it's very simple to display this one. It's a circle, right? It's a circle at this.x and this.y, this.x, this.y, and this.r being the radius. Perhaps we also should have a stroke, black, and the ball we should have it a nice color, such as I don't know, nice colors. We can look for some nice colors. Lime comes to my mind. Let's put lime. All right, let me run it now. Oops. Yeah. Yeah, it's as expected. We just said this.x is in the middle of the screen, but we want the ball to be on the pedal. That's why we actually created that. We made the constructor accept a pedal as an argument. So what we're gonna do, yeah, what we're gonna do is, first of all, update the this dot. We can do the calculation here, figure out, instead of this.x, we can put, for instance, this.pedal.x. Let's put this one just for the second. Yep, it's good. So the ball is moving with the pedal. And of course we can do the same for y. Or what we can do, we can update the this.x when the pedal is moving, right? So we can make use of the update method of the ball. So this gets called all the time. So what we can do, we can say this.x is basically this.pedal.x, and probably we don't want it in the left corner of the pedal, we want it in the middle of the corner. So we add also this.pedal.w plus over 2, so it's plus half of the pedal. And then this.y is basically this.pedal.y, so the y coordinate. And since the ball has a radius, we are raising up a little bit, so basically it's minus this.r. So each method works. So we can either put these calculations in the circle, or we can have the update method actually update at any moment the x and y coordinate of the ball. Anyway, let's run it. And we are in good shape. The ball is moving with the pedal, and I'm trying to hit space. Nothing happens, of course, because we didn't code that behavior. But from now we are one step closer to kind of make the ball move and leave the pedal and so on and so forth. So here, even if we had these constants, these ones are not doing anything because they get overwritten immediately. We can also put this expression if we want here. As you saw, anyway, it doesn't matter because they get overwritten immediately. But anyway, we can also put these expressions here. The program is still the same, although in this way we have a little bit of duplicated code. We can deal with this one a little bit later if we want. Anyway, now the main problem is, let's handle the space key, right? So if we are pressing the space key, what we should do? So we can also go inside the update, and basically if we press space key, we should do something. But what should we do? The display is still the same, right? The difference will be the update. So first of all, let's say if we press the space key, we set a variable. The ball is in motion or is not in motion, and then we'll take a decision based on that variable. So let's say with another constant here, this dot ball in motion or something like that, or in motion is false, because initially it's not in motion, it sits on the pedal. Now let's go inside the update and do what we did with the other class. So basically say if key is pressed or key is down. What was the key is down? Key is down. And we don't have a constant for space, but it's constant 32. We don't have a nice constant like we had left arrow, right arrow. So what we have to do here, if we are pressing this one, we just set this constant in motion equal true for now. Of course, we'll not do anything. I'm pressing. Probably that constant changed. It's a change in memory. But what we want to do, in the moment we press space, we switch the ball in a different state. We switch the ball in a in motion state. And when it's in motion state, we want to implement that logic that we implemented into the other programs with the bouncing balls, that they move on the screen, they bounce on the edges of the screen. So perhaps it's best to have two update methods. One update method when the ball is on the paddle, just to have this logic separately, because this is the update for this state, and to have another update method for the other state, right? So maybe it's a good thing to have two on. So this one should be update on paddle, right? Because this logic, it's valid when the ball is on the paddle, right? Only then we can press space and we put the ball in motion. Only then the ball is moving with the paddle. And we should have another one, update in motion, where we're going to implement the logic with the ball that is bouncing on the screen here. But we also have to put back our update method, because from outside we are calling update. But what we can do here, we can check this constant or this property. If this in motion, here we can say like this, if this in motion, then of course we're gonna call this one. We're gonna use this update method to say like that. Else, we can call update on paddle, right? All right. So now if we run the program, we should see a change, because in the moment we are pressing space, we switch this variable to true. So this method won't be called, this one will be called, which is not doing anything. Or we can put a println for now, launched, just to see if something happens there. Let's run it. Oh, update on paddle is not defined. Of course, this dot. Like this, right? Okay. So we are moving it, and now I'm preparing to press space. Space. Okay, launched. And it did. It's printing space constantly, and the ball is not moving with the paddle, because right now we are using the other update method. All right, so let's make use of now update in motion and implement the same logic that we implemented last time. So basically, we need for each ball, let me grab back my notebook and see what will be the logic. And what I can do, I can refer back to the other time where we implemented this one. So yep, is this page. So we have a ball that is trying to move. We can have two variables, dx and dy, that have either one or can be 1 or -1. Dx stands for direction on x or direction on y. So and what we can do if for each frame we are basically calculating where the ball is going by saying the next position of the ball. So x is basically, we are adding to the x plus equal dx, and we are adding to the y the dy. So if x is 1, basically we are going in this direction, and if dy is 1, it's going down. Perhaps we should also multiply into the speed, or with the speed of movement, because dx being 1, we don't want to make the ball move 1 pixel at a time. We want to move it a little bit faster. The interesting thing is here, when we are hitting an edge of the screen, because of these variables that we are constantly adding to x and y, what we can do is inverse them. So dx, we multiply it by -1 when we hit an edge, and dy we multiply it also in -1. This makes them change the sign. So if was 1 becomes -1. If was -1, obviously becomes 1, because multiplication with -1 makes it change the sign, right? So here, when we are hitting the bottom edge, when it was going down, basically the dy was 1, right? Because on vertical axis, y goes this way. It goes from 0 to 600. So dy was 1. When we are hitting the bottom and we are basically touching the edge, we multiply by dy with -1. So in this way, dy becomes negative and the ball will start to move up in this direction. And dx, we leave it alone. Notice dx is 1, so it advances to the right in both cases, right? But we get this nice effect of ball bouncing from the edge of the screen if we implement this algorithm. And I think we implemented several of times before, but I felt that it's best to kind of explain it again for new people that are watching this one for the very first time. All right, so let's have, for that reason, let's have other two kind of variables here. This dot dx, and initially, you know what, we can pick this one at random, right? So it's a random between -1 and 1. So when we're gonna hit the space, just to add a little bit of variety, the ball can go to the left or can go to the right at random. This dot dy, this times this one dy will be just -1 because we want the ball to go up, right? We don't want to go down with 1, right, when we launch it. So these are the initial values. We put them in the constructor. And now inside update ball in motion, all we have to do is implement that kind of algorithm that we said. To the x, we add the this dot dx. And eventually we set on the paper to also multiply it by a speed, because these numbers between 1 and -1, we want the ball to move more than 1 pixel at a time. So let's have, actually, yeah, let's have a property, this dot speed. Yeah, let's go it here, and they have also, like we had this one, let's have this dot speed, perhaps 3. We can tune it the value later. We can move 3 pixels at a time. Anyway, this is the formula for this dot x, and this dot y is we are adding to it the this dot dy, also multiplied by speed. And it's again, it's a linear motion. Let's save it and see how it looks. So we are moving and press space, and indeed the move. Bye bye ball. The ball moved indeed, but it left the canvas. It went to the left edge. So it's time to check for those collisions with the left edges. Basically check if x, the ball x becomes less than 0, inverse the dx. Or the same, if it becomes greater than the width, inverse dx. Or if it goes on top and tries to go through the upper margin, if y becomes less than 0, inverse dy. We should not do this one for the bottom margin, because the bottom margin, if we go to the bottom margin, it means we are losing the ball. So we should put a different logic. But at least let's implement it for the 3 sides here. So for the first one, if this dot x is less than 0 or this dot x is greater than width, what we have to do is basically this dot dx multiplied by -1. That's it. Let's do also for the top margin. If this dot y is less than 0, this dot dy multiplied by -1. Same logic. We'll have also to put logic. Okay, one step at a time. Let's move the ball in a position. Press space. All right. All right. Let's catch the ball here. Oops. What happened? The ball just tunneled through the paddle. And it's normal, actually. We didn't implement any logic there to check if the ball hits the paddle or not. Also, we didn't implement any logic to see if the ball, what's happening if the ball goes to the bottom edge of the screen. Because we don't want to bounce it back, right? We lose, yeah, we are losing a life in this game. So we are losing a ball, to say like that. Yeah, we are losing a ball. That's an interesting concept. So maybe initially the game gives us, like, say 3 balls, right? And if we are losing one, we decrement that one. And if we are losing all of them, it's game over and we start again. So let's also have this one. Yeah, it's a good thing. Let's have it also as a constant here. This dot balls or number of balls, let's say it's 3. And we'll basically inside the ball class. And we're gonna make sure when we go update in motion, if we are losing that one, it's basically decrement a little bit, right? So maybe you should display it, that one. Maybe. Yeah, maybe you can display the disbuilt balls to keep track of it. We can do that. But first, let's take care of hitting the pedal. And the way we're gonna do that, it's through a simple logic. So basically, if we are coming back here to the drawing board, what we want to see is on vertical. So this is our ball, right? This red one, although it's not red in the in the program. We want to check if the ball tries to go beyond this line, which is the pedal Y. This is the pedal Y. If it tries to go beyond this line, but in the same time, if the pedal is below the ball, so basically if the ball X is between the pedal X and pedal X plus width, then we are on the pedal. It means that we hit the pedal. So right, so if the ball is trying to go beyond this, below this line, but if there is a pedal below the ball, that means we hit the pedal. So that's kind of the logic that we want to implement here. So we can say here, if this, we compare again this dot y, if it's greater than this dot pedal, I think we have the pedal inside the ball class, right? Yep, pedal. All right. This dot pedal dot y, if it's greater than that, what do we do here? No, it's not enough. If it's greater than this, eventually we can also, the ball is coming at a different speed, is not coming 1 pixel at a time, so we can let it sink a little bit into the pedal. Eventually, if it's coming at a speed of 3, we may be in that situation that the ball is 1 pixel above the pedal, and in the next frame goes, because advances by 3 pixels at a time, goes 2 pixels in the pedal. Well, we can also say here minus this dot speed, I think. Yeah, we can give a little bit of a error margin here to make the to make sure that the ball is hitting the pedal. And now we have to check the x coordinate. And if basically this dot pedal dot x, if is less than this dot x, and basically this dot pedal dot x plus this dot pedal dot width, if is greater than this dot x. So basically the ball x is between the yeah, it's on the pedal, right? So if these are true, all these are true, it means we are hitting the pedal. And in this moment, what we are doing, first of all, let's reset the ball to starting on pedal. This dot y is this dot pedal dot y minus this dot minus radius. And the reason we are resetting it is because of that effect that can sink a few pixels in the pedal because of the speed, that it's an arbitrary number that we chose. Anyway, let's reset this here. It looks better because when we are launching back, we want to kind of maintain consistency, although it's not necessary. But anyway, we can reset it here. And now we inverse the dy exactly like we are inversing it when we are comparing with the upper margin here. All right, so let's run the code. And if we wrote that kind of formula correctly, we should be able to catch the ball on the pedal. Still nothing happens there with the bricks, but at least, yep, we can bounce the ball with the pedal. All right, and I think, if I'm not mistaken, the ball tries to sink a few pixels in the pedal because of the speed, but anyway, it's perfectly fine. We are bouncing it back and it's not a problem at all. All right, let's lose the ball this time to see what's happening. So goes below and it's perfectly fine. Launches back again for whatever reason. He probably will launch again. Yep, I know what's happening. We go beyond the pedal, but the ball somehow is moving off canvas, and sees that the paddle is in its way and it changes direction and spins back up. Should not be a problem, because what we can do, we can say if it goes off canvas completely, you know what, you lost the ball. And then we'll not have this problem anymore. So let's say this one, if this dot y, so we are talking about the ball, if it's greater than height, so if it goes completely outside of the canvas, what we can do is basically decrement that value, this these dot balls. We'll just decrement it for now. We'll see how to use it in the future. And then perhaps we should stop the ball, right? We should say this dot in motion is false. We just stop it here. Let's see. Again, we are launching it. Try to hit some bricks. Of course, not yet implemented. Bouncing, working fine. Let's lose this ball. Come on, come on, come on. And of course, the variable, resetting that variable in motion false, place it back the ball on the paddle. We also lost a life, basically, or a ball. Perhaps we should display the balls here just to visually see them. All right, so let's display them. We can go in the display function, one way of doing it, and we can, well, we can have a function here, function display stats. And we can call this one from the display. And in here, what we can do, let's not define this function yet, because we need to have access to. So let's do a text directly. Text is basically ball.balls at coordinates 10 and height minus 10, somewhere on the top left corner. Or bottom left corner, right? Okay, all right, let's put no stroke, fill black. The text will look nicer this way. All right, so we have 3 and we are launching 1. We should see basically, if we're losing it, we should see 2. Of course, and now the ball is on the paddle. Now, we are not checking if we reach 0, but it's fine, we can check it another time. Now we have that counter over there. All right, we are back into our program here. We are checking if it's going to the bottom margin. Actually, here, we don't have to check if it goes outside completely. We can check is basically greater than the paddle Y. Yeah, once it passes the paddle entirely, plus maybe some speed. Yeah, if once it passes this expression entirely, it's basically we can consider the ball as being lost. Let's see it. Yeah, because we don't have to. We got it here. Anyway, we can leave it compare it with height. Yeah, it's fine. So all right, so I think we kind of finished this one, the collision with the paddle. Now we have to check for the collision with the bricks, right? We can put also the logic here, but this will get pretty quickly pretty messy. So better than this one, instead of having again another expression like here, so let's put a comment here, collision with paddle. Let's have here collision, okay, collision with screen with edges. Okay, and this one is basically loose ball, so that's fine. So rather than have it one of this and collision with bricks, I expect to be a little bit more complicated than this one with the paddle, because we have to check for all the bricks. So we'll get a humongous update in motion method. It's best to extract that kind of logic in another one. So perhaps the bricks should have, yeah, let's go in the bricks. We go in the bricks class, and let's say the bricks have a method hit, right? So and we are it takes an argument a ball. So what this one will do is basically we're gonna ask the bricks, are you hit by the ball? And if they say yes, then okay, basically we'll do something. Let's say this one returns true for now. Will return true or false. So here check if the returns true, or say returns true if the ball if the ball okay hits any brick, right? So we're gonna ask this guy here, which is a method, we place it inside the bricks. So now if we come back to our ball update in motion, when the ball is moving in all the directions here, we can say, instead of having a complex logic here, we say if this dot bricks, oops, no, we said this dot paddle. Let's make the ball accept not only the paddle as an argument, but accept also the bricks class as an or the bricks instance as an argument. So let's place it here. Let's say this dot bricks is bricks, because we don't want to access the bricks from outside. We want to pass it in. And let's go where we are actually instantiating the ball and pass also an instance of bricks. All right. So if we are looking at this code, actually, we can see bricks is an independent object. It doesn't know of anybody. Paddle doesn't know of anybody, but the ball knows both about the paddle and the bricks, and will keep a reference to both the paddle and the bricks inside, which is kind of cool, because now the ball can verify collision with the paddle and can verify also collision with the bricks. All right, so we pass the paddle and the bricks, because this is the order of the argument we put on the constructor here, right? Paddle and bricks. All right, so this allows us now to go inside the update ball in motion and invoke that method hit, and that one and now because and it's a good thing that we make the method accept an argument a ball, because the bricks doesn't know about the ball, so we'll have to specify it. So which is the ball? The ball is actually this. It sounds, it looks a little bit funky, the syntax, but we are invoking the method hit on the bricks object, and we are passing a ball, which is this current ball, as an argument. Anyway, so if this one returns true, it means we hit a ball. We want to make our ball change the direction again. So we are basically this dot dy multiplied by -1, right? We multiply by -1. We change the direction. So let's say here check collision with bricks. Let's see. I'm gonna save it, run it, and let's see. Oops. Oops, this is not good. Not good at all. Let me run it again. What did we do wrong here? So before we had this one, before we had this one, it just worked fine. Oh, of course. This one returns always true. And we are changing constantly the direction, but we didn't hit any brick. The ball didn't get the chance to actually go and hit any brick. So, okay, let's see. Let's go inside this one and let's try to implement it. And obviously it was not a good idea to return true from there. So what we want to do basically in here, we want to loop through all the bricks, right? And check for all these bricks if we are hitting any of the brick, right? So if we are hitting a brick, we can return true. Let's do that one. So we're inside the bricks and we have access to the bricks array. All right, we're in good shape then. So we can say for let brick of this dot bricks. We iterate through all the bricks, and now let's we need to check now. Back to the drawing board. The collision between the brick and the collision between the brick and the ball is a little bit more complex. So basically, with the paddle. So basically, we can have the brick this way, and the ball is basically coming this way, right? So we need to see if this small rectangle, a small circle is hitting this rectangle. But the problem is that although it looks similar with the pedal, what's happening on the canvas here, the ball may hit the brick from below, which is fine. We can check it like we check with the pedal. The ball also may come this way, may reflect from the screen, and may hit the brick from above. So we have to check with both edges. That's one way of doing it. We can do this kind of comparisons, check with both edges. Second, so that's one way, check with all edges. Second method, we can implement a collision detection between a circle and the rectangle, generic one. So we specify the x and y and radius for the circle, and then we specify the parameters for the rectangle, x, y, width, and height. And this basically generic method will return if the two are kind of overlapping, which is, it's very easy to implement. And we can actually implement it, but this time we're gonna do something else. This method is available as a library function. So we're gonna choose this option, and in a future, probably in a future program, we're gonna see how to implement these methods ourselves. So let's look a little bit at the library. I think it's under, let me locate it here. Should be some, collision between shapes, and we need a function to collision between point and line, point and rectangle, two circles, circle and rectangle. This one we need actually. It's called collision circle rect. It's available as a built-in function, and we specify the circle parameters x, y, and radius, and the rectangle parameters x, y, width, and height. All right, so collision circle rect, this is again the function that we want to check, and it will return a true if basically the two shapes are colliding. All right, so what we want to do, we know these parameters there. We know the ball x and y and radius. We know also for these bricks the x and y, and then with the width and height, we need to see if they collide. So let's have it in a variable. Let's collide equal, and we invoke our function collision circle rect, and we pass first for the circle and then for the rect. So first will be the ball.x and ball.y and ball.radius, and for the bricks will be brick.x, x brick.y, and since we didn't store the width and height, is basically this dot brick width and this dot brick height. Oh, all right. So this has how many? 7 parameters, right? 3 for the circle and 4 for the rectangle. All right. So this one will be true or false if we are hitting, because we are iterating through all of them. So what we are doing here, we can say if we hit one, then of course we can return true like we did before. Otherwise, if we finish the entire loop, the entire circle, we can say return false, and now we should be in good shape. Let's run the program again. Hit. All right. Yeah, it's working as expected. But we still have to do a little bit of work, because what we have to do is actually we need to remove the brick that we hit it, right? We don't want to just play against the bricks like we're playing against the top edge. So let's try to remove that one. Actually, you know what? We can create another function where what we can do, we can remove it immediately here, right? We can remove it in the hit method, and in order to remove it, each time we want to remove an element from an array, it's best to kind of iterate to the array from the end to the front, because when we remove an element, the array indexes get reassigned, and we may skip an element. It's bad thing to do that. So we can change this one. We can use a instead of a for off, we can use a typical for or a regular for I. So for I equal this dot bricks dot length as long as I greater or equal than 0, I minus minus. And let's have it, you know, let's have it the brick here. The object brick is basically this dot bricks of I. And nothing changed until now here. So what we can do, if we detect the collision, before we are returning, we can say this dot bricks dot splice. We also remove that that element. So I position 1, just like this. Should be enough, right? And if we eliminate one element from the array, the display should find. You know what we can do? Just to make sure that we eliminate it, let's go back here where we are displaying how many balls we have, and let's put another kind of statistic. So this one is basically we're displaying how many balls we have. And let's have another text. Yeah, let's have another text. How many bricks there are on the screen? Bricks. So perhaps this one is minus 30. Like this. All right. So if, okay, we have 3 bricks, not ball. So this is basically bricks dot length. No, bricks is actually the object dot bricks dot bricks, and bricks is the inner member that is that array, right? So bricks dot length. Yeah, there are 10 on the screen. All right, let's hit one. Oh, cannot read property X of undefined. Where is that one? Let's see. It's probably here. No, display, update. Let's see. Where do we have it? Brick. It was just working fine before. Oops. Yep. When you iterate from the back to the end, the last indices is length minus 1, is not length, so should be correct now. Let's run it. All right. And we also notice on the screen there that the balls, that the bricks is decrementing. So it's so cool. All right, and you saw multiple bricks at once. Wow. And now the last one. All right, so we have 0. We lost this one. But now we are just playing with an empty space. So I think the game is 90% there. We kind of accomplished all the wiring, and now we have to do a few more checking against some variables. You know, if bricks become 0, basically go to the next level or something like that. If balls become 0, you lost the game. And then, yeah, everything is fine at, at this point. Let's go here a little bit in this function, because in order to make it a little bit more realistic, I always like to play some sounds. So let me locate some. No. Tone 1. I'm trying to locate some sounds that when the ball is hitting the pedal or is hitting the bricks, something like that one, to make some nice realistic sounds. It will look a little bit more realistic, the game. Okay. Okay, click 2 for the pedal, click 4 for the rest, and we can choose other things. All right, so where is hitting the pedal? Here. What we can also do, we can have a sound, click 2, and if we are hitting the bricks, we can have a sound, click 4. Also, when we are hitting the edges, we can make the same sound for now, or you can pick a different one, it doesn't matter. Let's see if it's working fine. Okay. Nope. Let's. Oh, there is some problem with my computer. The sounds doesn't get initialized on the first run. All right, but it's working now. Looks much better, right? All right. Let's see. What do we have to do with this one? And since we are in adding a little bit of effect to this game, I'm thinking, what about to make those bricks fall out when the moment they are hit, not just disappear like that, right? So if we go in this array here, when we are hitting, maybe we should not remove it. We should mark the brick as being hit, and then, oh, of course, we have an empty update. It's a great opportunity to add some logic in the update. Bricks, they don't have any code written in the update method that anyway gets called for them. So we can put here some logic to kind of move, if for all the hit bricks, we can increase the Y coordinate to make them down. So, all right, what we can do in here, we can basically, we cannot remove it. First of all, let's take this one. So if we are colliding the ball with the brick, we can mark the brick. We can inject a property hit and say true, right? Also, you know what we can do? We can also check here when we are trying to hit the balls, if the ball is already hit. If ball hit, we can continue. So we can skip the ball if we are hitting twice. We may never run into this situation, but it doesn't hurt to have this condition here. Now, if we are running like that, we are not removing it, we are back to square one. But what we can do in the update, we are actually should iterate through all these balls that we hit and make them fall down, or we can remove them there, something like that. So let's iterate again with the same kind of code in the update. We are also iterating from the back of the array because we want to remove it. So first of all, to make sure that the code still runs, we can say this.bricks.splice I, 1. So we move that logic here. It's still not falling, but let's make sure that the code still runs. Oops, and it's not running. Let's see. Oh, of course, because we are we want to remove it only if the brick is hit. If brick.hit, then we splice it. So if we run it, all right, so it looks correct, but let's make it fall down. So what we can do is basically, if brick.hit, we just make it fall down really fast because we want to kind of make them disappear, not stay on the screen. So brick.y plus equal 20 pixels should fall pretty quickly down, right? And now we should check if the ball goes outside of the canvas, and then we remove it from the collection. If brick.y is greater than height of the screen, then we can remove it. So still we have to remove the bricks, right? I think we're in good shape. Let's run it, and let's play it. All right, all right. And what kind of hit we were able to put the ball and go behind them. Let's run it one more time. Wow, it's always that easy. Let's run it one more time. Let's hit it here. This time, yeah, okay, let's hit it one more time. Oh, we are not changing the direction, or are we changing the direction? Let's see. Because we should change the direction. Let's hit it from below. Didn't notice that. No, for whatever reason, we are not changing the direction like we used to do, right? So if you put back the code here, we are changing the direction fine. Let's check. Yep, this one is working fine. Yep. So why our effect? Oh, it will be a shame not to be able to implement it nicely. So if we are hitting one, we are increasing the Y, right? And if it's greater than height, then we remove it. looks like fine to me. And here in the other one is basically we are just okay, and we put a condition here if we are hitting it twice, kind of. So this one returns true if we are colliding into it, because when we're gonna invoke it, we're gonna say if brick hits, we inverse, we change the direction, right? So our ball should have changed the direction in the moment we hit this one. Brick hit is true. Anybody on the chat that can spot the error here? If you spot the error, let me know. I'm looking at the chat. All right, let me look a few more minutes. If we'll not be able to implement it, we'll fix it for next time. But if you spot the error, let me know. All right. So we are going through all the bricks. We can check if the brick is hit. Maybe we didn't put, yeah, hit is here, and here hit. Huh. So we are marking it as being hit, and we are returning immediately, which is fine, because we want to return true, right? And outside of the for, we are returning false. What this has to do with this one? And those bricks starts to fall, but that's why we have this one. We check if it's already hit. We don't want to basically do anything. We want to check with the next one, right? So this condition is important, because as the ball is falling, we don't want to hit it second time as the brick is falling. So on the update here, if only the hit bricks, we are increasing, and if brick is not high, we remove it. Very peculiar. Looks totally fine to me. Let me see it again. Run it. No, the ball just goes straight to them. Although it tries to change the direction when it hits there. All right. Let's see. We have the collision. What is the difference then here? Let's look how we are invoking it. We are invoking in display and update. And that may be a problem. That may be a problem because, or no. Yeah, I think that was the problem. No, that's not the problem. That's totally not the problem. So we are updating the bricks, the paddle, the ball. Oh, I know. I think this is the problem. It still has to do with the order. The bricks, we need first to update the ball. Yeah, the order is different. All right. I think the ball, okay, we can put the ball, okay, we can put the, yeah, we can put the bricks at the end. We can even inverse this one, doesn't matter. So we can have the ball, paddle, bricks. Let's have it in the same one here. But I think this one may be the problem. And if it's working, I'll tell you why. If it's not, scratch that. Let's see. Yep, I think it's working. Let's let me run it one more time. No, it's not working. It's not working. Come on. What will be the problem then? So we have the bricks update is the last one, right? Because the ball update is coming first. So this one is coming first. And it's coming first, it's invoking that one and should change the direction. And then now the other update is coming. This one is coming next. So by this time, the brick should be already marked as hit and should start falling down. And our ball anyway should come back the other way, should change the direction. Alright, it's working for that one. No, it's not working. Not working all the time. Ah, alright, probably. Probably we can park it any. Yeah, let me read me the chat here. Looks like the ball, okay, still goes up. It's kind of going for the bricks. Why? Yeah, indeed, there are some good suggestions on the chat. The brick should go off after 2 hits. Indeed, we can put a property to the bricks, how many times we hit them before they disappear. Actually, we can have a combination. Some of the bricks can be harder to destroy than others, so they can have this hit counter. And when we are hitting once, or when we are hitting, we decrement the hit counter, and only when we reach 0, we destroy them and they disappear. We can implement that one. Let's let me take one more minute and see if I can spot the error here, why this one is not working fine. So starting from the bottom here, the order of updates is like this: ball update and paddle update. Paddle should not matter, just ball update is first and bricks update is second. So ball update is happening. Ball.update, it's happening, and here we are checking if we basically hit the, we are checking it if we hit the bricks, we are invoking that bricks there, that hit, and if yes, we change the direction, this.dy equal -1, which is fine, right? Because that's why we designing that actually worked fine until we introduced that, we tried to introduce that effect. And now if we go back to the bricks, well, bricks will have also an update, and we are iterating and we check if the brick is hit, we are increasing their property, and if it's going out, we are splicing it. So it looks correct to me. All right. So only for the hit, okay, it's fine. And then inside the hit here, basically we iterating through all the balls, all the bricks. Here, let me use the other kind of iteration for let brick of bricks, this dot bricks. Anyway, it doesn't matter. Or you know what, we can keep the first one, because if we want to remove it there, we can remove it. This one I don't expect to solve the problem unless we had, yeah, no, it's not solving the problem, of course. And actually I prefer the other kind of iteration at this point, because if we want to revert the code back to remove it here, we'll remove it here. But anyway, if we collide here, so collide is true, what if we don't have this one, although we need these ones, because if we hit a ball, we should not bounce back from a falling ball. So that's the idea. And still doesn't solve it anyway. Maybe the ball will hit a falling ball, a falling brick. Anyway, so if we are colliding, we mark the brick as being hit, which is brick.hit is this one, and return true. Very peculiar. Okay, one more thing that I want to do here. If brick.hit, I'm gonna remove it here immediately, like we had it before. Let's see if this one is working. All right. Now this one is working fine. Very peculiar. It's like we are hitting twice the same brick. So because we are not removing entirely, the brick tries to go a little bit down. Let's use more brick. Yes, we're gonna use more bricks. let me pass this problem here. Let me fix it in some way or another one, and then we're gonna advance the level and use more bricks. But that will be next on the list. Use more bricks. So if we are removing it entirely, the ball of course doesn't hit it twice. But we put a condition here, because if we hit it, it's basically its ball is hit. When we try to check if it's hitting it, we are returning true. Oh, ball hit, brick hit. Ah, come on. Don't tell me this was the issue. Let's let's try it again without that one there. Because this, I was just trying to put a condition to check if the brick is already hit. Ignore it. Like this one is a ghost brick, is not bouncing from it. Let me see if this is the thing that caused us so much debug session. All right, one is good. All right, work celebration. Let me play a little bit. It's fine. So now let's take care of the game. Let's now let's now see what we are doing if we are losing all the balls. Also what we are doing if we are basically destroying all the bricks. That will be next, right? But before that, let's look a little bit at the code and let's see how it's structured again. This is the entire code. We have three classes: bricks, that keeps the logic for the bricks, the paddle, the ball. We don't have a class for the brick, although we could have defined one, but what we did inside the brick, we created these inline objects for each of the brick and we placed them inside. And since they don't have behavior, it's perfectly fine, especially in JavaScript. Now, what we can, and also we have here the loop function, which is the game loop. What we can do to tidy up a little bit the code, we can also make a game class. And let's do that class before we advance. Let's have a game class that will have follow the same pattern. We have a constructor. We'll have a display. And we'll have an update. And the reason I'm introducing this game class here is because I want to take all this loose code that we have here and place it in that inside that game class, right? So just to time it up, like the game class keep tracks of you know, the bricks, the paddle, the things like this. So let's have it, instead of having global here, the game class, we can have it inside the constructor. But of course, if we are doing this one, we need to store in some properties. So say this.bricks, this.paddle, and this.ball. And here is basically this.paddle and this.bricks. So looks fine. And then on the update, on the display, we are doing what we did here. And on the when we don't need this one, and on the update we do what we did here. So we don't need an update, a global update function. We can do this one. Of course, let's not forget that this dot. So let me clean up the code a little bit. I'll put you some music. All right. All right. This dot, display, this dot, this dot, this dot. I'll extract also this one in a separate function, in the separate method, display stats. This dot display stats. All right, and this one has this this dot, this dot. Okay, I think I'm done. We'll see when we run it. But now, because we have a game, we don't have to kind of instantiate all those from outside. All we have to do here, let's say let game equal new game, and just say game update and game display. And the entire logic now it's contained in this class. So our code now the loose code outside is just basically the loop, the game loop, and we are making use of the game. Let's run it, and if we don't have an error, we should have the same effect. All right, sounds fun. Now, what we can do, we can take care of that. The reason I encapsulated this one inside the game class is because I want the game to keep track of the balls and the bricks. So we can do here, after each update, basically after updates, we check the state of those variables, balls and bricks. So let's check first the one for the balls. If basically this dot ball, right? So this is the object. This dot ball dot balls. I think we named that balls. If it's less or equal than 0, it should not become less, but anyway. All we have to do, so if we lost all the 3 balls, we're losing the game. We can send them to a game over scene. We can do these kind of things. Anything at this point. For now, I'm thinking just to re-init the game in the interest of time. We are running late here. We just re-init the game again, right? So perhaps all these objects should have an init method. So we can say then here this.bricks.init. So we are re-initting everything. This paddle.init. We put back the paddle in the middle of the screen, and this.ball.init. Right? So we'll make it go again. So let's have them really quickly. Bricks.init. And here I think we can make use of some of this code that is in the constructor. Instead of being in the constructor just like it is this, currently we can move it into the init. So what we can move into the init is create bricks. Yeah, you know what? Let's move the create bricks, because this one is basically doing the entire logic there. And what we also can move in here, in preparation when we advance, we can also reset the rows and columns to 2 and 5, because we want to create levels. So once we advance to the next levels, these variables, maybe we increase the rows and we increase the columns to the next level, and maybe once we won the first level, we go to 3 rows, 4 rows, and so on, but then we can reset them here. And if we reset those there, we'll have a little bit of a problem, because yeah, this one need to be recalculated each time, right? So perhaps we can place them in the init, or we can place them in the create bricks like we wanted initially. They need to be recalculated because we'll have a different number of columns. All right, so I think it's okay for now, the init for the bricks. Let's see for the other one, for the paddle, right? What do we have to do for the paddle? So probably we'll have to just re-init the position of the paddle, put it in the middle of the screen. Yeah, perhaps it's enough. I think the bricks are the more critical one when we need them just to have them. So for this one, we can just put this expression back again. So this one becomes in the middle of the screen. And then if we are thinking about the ball, when we are initting it, we should basically, yeah, let's go to ball. We can make it, can also write an init method here. All right, so first of all, these balls becomes 3 again, because this one, they get decremented, then we reach 0. And yeah, this in motion becomes false again, right? Because maybe we're losing the game, the ball is still in motion, so we want to reset it. The speed and the rest, maybe a few. For now, we'll let just these 2 ones. All right, so this is happening if we are losing all the balls. And we can, oops, what is the error? Length, error of undefined length. All right, so it's in some of these inits that we didn't. Oh, all right. So once we do these inits, because we moved in here, I think, because we moved the code, we have to call it. The other ones, I don't think I moved the code. It is this dot init all the time. Don't forget about this dot. And yeah, okay. And I'm gonna lose 3 balls really quickly to see what's happening. balls too. Notice there in the bottom left. Come on, don't hit it. And let's lose the third ball. All right, and we are getting back at the beginning with 10 bricks and 3 balls. As I said, we can make a game over scene and display some other information there, but you know, it's fine for now. Let's now also take care of the other situation there. So we are back in the update of the game, and we are checking after each one, what if we destroy all the bricks, right? So if this dot bricks, and we have a bricks array inside, dot length, if less than 0, so basically we destroy all the bricks. Well, what we can do, we can do something similar to this one, but we can call an advance. So we are advancing the level, right? Okay, we destroy all the bricks, advance to the next level, and pedal. Actually, yeah, this one we don't have to define an advance. A pedal we reset in the middle, and ball we advance in the middle. So it's all about the bricks this time. What we are doing is basically if we are need to advance. First of all, we can say we can do that logic that we said. We can increase the rows and columns here. So let's have an advance. And then we can say this.rows plus plus and this.calls plus plus. We can have just this one. Now we have also to call create bricks like we do in init, because nobody's calling create bricks. So it's looking like init, but instead of having a constant, we are getting to the next level. So let's see how it looks like. All right, let's put some music. Let me destroy all of them. And now it's a good thing that I started with just 2 rows and just a few bricks, because imagine having multiple ones. One more. Come on, come on. Come on. Come on, ball. Move faster, faster. Oh, it's not in a good position. No. Ah. All right. And now we have indeed 2, 4, 6 columns and 3 rows. So we advance to the next level. So at this point, yeah, this is what we can do, or perhaps we can introduce even some colors if we want. So let me introduce quickly some colors here. So let's say each level has the bricks are appearing in different colors equal, and we started with orange, right? And perhaps we can have a teal color for the next level, and we can have a magenta, and we can have a blue, and we can have a yellow, and we can have a red, and we can have a green, and we can have a, you name it, maroon, so on and so forth. So we can have this one like a constant, and basically when we are advancing, actually not when we are advancing, yeah, when we are advancing, when we are displaying the bricks, we can have each brick in a different color with all sorts of improvements, so many things that we can do this one. But let's say they are in a single color. So instead of filling with orange, we have to figure out what will be the great color to choose that one. And we have to basically look into this array based on what we do have, like a very we do have yeah, maybe we don't have the level, but we as a variable, as a property, but we have the rows, maybe based on the rows. Maybe, you know what, we can start at 1 row. We can start with 1 row of bricks, or maybe 2 rows. Yeah, let's start with 1 row. And then the color here will be basically this dot colors. It's an array, right? So we are indexing based on this dot rows, minus 1. But we are taking modulo of this dot colors dot length. In case we finish all the colors in that array, we'll start over. That's the idea with that modulo. And let's fill with this color. All right, we fill with the color. Should be in good shape. Let's save it. All right, one row of bricks. We're hitting it. All right. All right, I want to see the next color. All right, and we have teal. And now we can, you know, go and finally beautify it. Let's pick this one, field, background field. Let's go in the game here, perhaps. Yeah, it's anywhere at this point, basically. Let's go in the constructor of this game here, and we can say background. We can pick any, not field, we can pick any of these ones. I just selected field because I saw it before, but let me put field, and if we don't like it, we can choose different one, field. This is a predefined kind of background that puts that image, but if you're doing this in a different platform, there are different ways to display an image, or just put a color. And let's put also, since we did this one, let's put also a little bit of a background music. What background music will be appropriate to this one? Yeah, let's pick this one. 8-bit intro. Where we are, okay, in here. Again, these are some niceties from the platform, but of course, if you're doing this one in a different platform, you can just keep the music or research how to can you add some background music. All right, are you ready to play the game? Let's try. 1, 2, run. Oops, no sound. Again. 1, 2, run. What's happening? Oh, first of all, let me put a little bit of a volume. I think it accepts a volume here. I'm not sure if it's on my sound card, but I had a little bit of interference with the sound. Yeah, I'm not sure if it's from me, but right now the sound, I have a little bit of interference on my computer. But anyway, this is the game. And what other things can we do? Like it was mentioned on the chat here, we can put basically a counter on each brick. How many times does it take to hit it? And in that moment, basically when we are hitting it, we are not destroying it completely, but we are decrementing the hit counter. So you have to hit it several times. Eventually we color in the different shades of color. First one is dark orange. You hit it second time, become a lighter orange. You hit it the third time, lighter orange. You hit it the fourth time, boom, the brick disappears or falls down. We can do that one. Another thing, rather than arranging them in this kind of rows and columns pattern, we can have for each layer, basically, let's try to draw here on the on the paper. We can basically have them arranged in a predefined pattern. For instance, let's say initially they are drawn in that rectangular pattern, but maybe later on we can have them make a formation, like, you know, some sort of nice formation like these ones, perhaps. And here we can have in between, you know, or we can have different colors. So for instance, the red bricks can have that hit counter maybe 3. So this one will be harder to hit. And then we can have, you know, the blue bricks, you know, can be just for decor here blue, or maybe can have a different property. When you hit them, maybe fall down, and the yellow ones, when you hit them, they fall up or something like that. So this is a formation, and on the next level we can have bricks in a different formation. So right now it's up to your imagination what you can do to the game. For now, in the interest of time, oh, another thing, you can make the ball move with a certain acceleration, not with just a linear motion. The same with the paddle. So all these are possible enhancements. Perhaps we should create a version 2 in the future if you are interested. For now, I saved this one on the chat. You have it there. Click on the link, load it. I'm gonna place it one more time on the chat just to have it. So I think this is the program. Let me run it. Yeah, this is the one. So breakout clone. Feel free to take it, extend it, reskin it, change the background image, share it. If you want, you can. If you have a blog or website, you can embed it inside your blog or website. You go here on the share menu, and you have here the snippet of code that enables you to embed this one. You know, and if you create something interesting, please put a comment on the chat and share what you built. That's it for today. We don't want to go over time, but I hope you like it. I'm expecting you to join the next stream where we're gonna implement the Pong game. I think that one will be a little bit easier and faster to implement. But anyway, I hope you had fun. Thank you for watching. Happy coding and see you next time.